Okay, kids, here we are today making a simple pendulum video, a demonstration for you. We're going to check out the effect of length on a pendulum, or check out the effect of amplitude on a pendulum, and mass on a pendulum. So what I've got is made some homemade stuff, so I don't want to hear any, I can't do it at home, it's too difficult, I couldn't do this. Of course you could. Look at the stuff I'm using bananas. Okay, I'm using bananas, some lampy thing. I've got some string, okay? String, was I cut with a pair of scissors. Not just one scissor, but a pair of them. It's funny. And I also have a little bit of masking tape. So I'm using this as a pendulum. I'm using my bananas as a pendulum. In fact, there's a name for the thing at the end of a string that a pendulum is made from. In fact, it's also words for springs. And when a spring is moving back and forth, like a mass on a spring, boop, 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 or a pendulum, bloop, 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 back and forth, this back and forth, there's a name for it. What is it called? It's a physics name. I'm not making this up, it's a physics name. Oh, wait. No, you don't know, do you? Okay, I'll give you a hint. You ready? What do you call a guy floating down the river with no arms and no legs?
Mr. Kazura!
No, that's a bald guy floating down the river. Bald guy. Miss Russo Stitt. Yeah, Miss Russo Stitt, okay? What did you learn in anatomy, okay? I said a guy floating down the river. Besides, she has her arms and her legs. She doesn't have a lot of height. She's a little vertically challenged. She's about that high, but she's so cute. Yes, she is. Okay, where was I? The answer? A bob. A bob. Get it? Floating down the river, no arms, no legs, bob. Okay, okay. It's a physics joke. It's funny. Now, these are called bobs. So we're going to use the first bob as my thing of bananas. Why did I use 3 bananas and use a masking tape? Why did I do that? Because these are clearly different mass. This is like so light, and this is like, so I can barely lift this up. As a matter of fact, my assistant had to help me lift this up, otherwise I couldn't have done it. The bananas are really heavy. So we want to demonstrate the difference in mass because we have 2 different masses. We'll do it. Okay, let's get going. So what I've done here is we've strung up some bananas, and we need to know the length that we're using because we want to test that. So what we do is we measure from the base of the pivot. Boop, 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 boop. We measure from that, and we measure to the center of mass, center of gravity of the mass. And the center of the banana is probably like, probably about there. And so if I measure from the center of the bananas, that's 30 centimeters. I've got a 30 centimeter ruler here. I don't have a meter stick, but we can use the ruler. 30 centimeters here, and about another 1, 2, 3, 4, 5, 6. So that would be 30 plus 6. Anybody have a calculator? Oh wait, go ahead, calculate that. 30 plus 6. 36? Okay, trusting you. So 36 centimeters. So what we're going to do is start this going. We're going to time it. We'll time it for 10 oscillations. An oscillation, or one repetition, is back and forth, not just out, not just back, but back and forth. So 1, 2, 3, 4. Okay, like that. So I have my lovely assistant who's going to do the timing. Wave hi to the kids, lovely assistant. There she is. Okay. Now she's got her timer ready to go. And when I say ready, set, go, she'll start timing. Okay, you need to get this stuff down beforehand, otherwise it's a mess. Okay, so here we go. I'm going to pull this back a little bit. And on the count of ready, set, go. 1, 2, 3. Count it home. 4, 5, 6, 7, 8, 9. Stop. Okay. And we've got a 12.26 seconds. We're going to have to write that down. There ain't no way I'm going to remember that. You writing it down? 12.26 seconds. This is for the banana. And the length was 32 centimeters. No, lies, 36. 36 centimeters, right? See, you should be listening. 36 centimeters. So we're going to write that down too. Importante grande. All right, now, next thing we're going to do is we're going to, actually, let's remove the bananas. And, no, actually, we'll try one more thing with them. Some of you are probably sitting there going, you know what? You only pull the bananas back like so far. Oh, what if you pull the bananas back just a little bit? Or what if you put them back way back here? That'll make a difference too, right? That'll make a difference. That's what I'm talking about when I said amplitude earlier. The amplitude is how far back we pull the bob, the bananas, but it's a bob. And so that gives me a height differential from where we started from. This is actually called the equilibrium position. The equilibrium position, I pull this back, And now I've given it a little bit of amplitude, more amplitude, more amplitude. Let's see if that makes a difference. So I don't remember how far it was I pulled it back last time, but this time I'm going to pull it back hardly at all. So I won't pull it back very far. I'll pull just a little bit, and we'll get a time on this. Lovely assistant, are you ready?
I'm ready.
Okay, ready, set, go. 1, 2, 3, 4, 5, just a little bit. 6, 7, 8, 9, 10.
You messed me up.
We're gonna try that one again. Yeah, we'll try it again because I screwed it up. Okay, ready? Here we go. Okay, we're a comedy team. It's so funny. Here we go. Ready, set, go. 1, 2, 3, 4, 5. Stay focused. 6, 7, 8, 9, 10. All right, 12.25. Holy crap on a cracker! 12.25 seconds. Do you remember what the first time was? 12.26 seconds. That is what I'm talking about. That is like boom, 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 spot on. So the amplitude, how far I pulled it back, doesn't seem to make a difference. And so I pulled it back just a little bit. We got 12.25. The first time I did it, I pulled it back to about yay far. A little farther, 12.26 seconds. The amplitude doesn't seem to make a difference. Okay, let's take the bananas down. These poor bananas. Now what we'll do, we have to remember that number, 36 centimeters. What I'm going to do is tie on, actually I can tie this on here. We'll tie this other doohickey thing. The doohickey thing that I'm tying on here is the masking tape. And the masking tape, all right. Now, that is clearly longer than 36 centimeters. So what I want to do is I want to try to get that to be 36 centimeters, which if I measure that out, that would be 30 plus another 6. So I want the center of the masking tape to be about right here. So that means I'm going to have to wrap this around several times. So I'll just go ahead and just kind of eyeball this for the first couple of times and know that when I do this, I'm shortening the length as I'm doing this. Okay, I don't know how many centimeters that is, but let's give that a shot. I think that's too much. Yeah, that's too much. Back the truck up. Boop, 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 boop. Back the truck up. That's, what was that? So that's here. Like maybe back it up one more. Let's see what that is. All right, so from the pivot down the bottom, okay, that's 30. 6, boom, nailed it. Boom. So I'm talking about. All right, you ready?
No, wait.
Oh, no, this is not ready.
Okay, I'm ready.
This is not ready. Okay, now what we're going to do is time this same length as the bananas that we used, but we have a different bob. We're using a much lighter bob than the 3 bananas. Let's see what we get. Now we were showing earlier that the amplitude doesn't make any difference. Maybe this time I'll pull it back even a little farther this time at the 36 centimeters, and we'll see what happens. Ready, set, go. 1, 2, 3, 4, no meowing. 5, 6, 7, kitty cat. 8, 9, 10. 12.29. You show the studio audience, people, because they're not going to believe me. They don't believe me. I usually wear a tie. I don't trust anybody who wears a tie. Okay? Mr. Hawker, he wears a tie. You do not want to trust that man. You do not want to trust him. 12.29. So that was the masking tape. 12.29. I'm writing this down. I mean, you're probably thinking that I'm just faking it. Yeah, you're not showing me anything. Blah, 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 blah. No, I'm writing it all down because we need to have all this information down when we do the math.
Math? I didn't know there was going to be any math involved.
It's physics, people. It's physics. Of course there's going to be math involved. We're just doing a little demonstration here. Okay, so you also saw that I pulled that back pretty far. That length pretty far back, still the same times. Different mass, same length, still the same times. So we've used different masses, we've used different amplitudes, and we at the same length, we keep getting the same time. So apparently amplitude and mass have nothing to do with the time period of an oscillation. Let's check out one more thing. Let's check out the length, because we've been using 36 centimeters. Let's try wrapping this around several times. and have this short little length. You know, cute, it's so cute, isn't it? So cute, yes it is. Okay, now here we go. 10 reps. I'm gonna pull this back. How far would you want? Billy, focus. Thank you, Billy, pay attention. How far should I pull it? Billy, you make the call. This good, Billy, good? Thank you, Billy. Okay, focus. Get off that cell phone. Okay, here we go. 10 reps. Ready, set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop. 9.39. Much shorter. 9.39. So we saw shorter length, quicker time. That means the time period, how long it takes to go back and forth. Well, you got to show this to go. I say they don't believe me. See, 9.39. Yeah. So that means that it's a shorter time period to go back and forth with the shorter length. Now, we could go for kicks and giggles, and I know you kids are just having so much fun enjoying this video. Okay, so we will just do one more for you because you just don't want to go away. You want to stick around forever, don't you? You just want to keep watching physics videos. Who doesn't, huh? Okay, so here we go. Now, the length of this is pretty long. Let's just make sure it's longer than 36. So that is 30, 49, almost 50 centimeters. That's a long pendulum. So let's see what happens with this. We'll pull it back just a little bit. Okay, well, again, we're just playing around with the amplitude. No, actually, let's pull it back about the same amount as the last time. Or it'll be consistent. All right, ready, set, go. 1, 2, 3, 4, 5, 7, 8, 9, 10. Oh my gosh, it's forever. Forever. Show this to the audience, people. 14 point. Oh, we lost the time. It was 14.36. I hit it. It was my fault. It was 14.36 seconds. 14.36 seconds. There it is. It came back. 14.36 seconds. So we know that the length has something to do with the time period, but not the mass, not the amplitude. That's what I'm talking about. That's homemade science.